Hey everybody, section 10.6. Let's get right into it. You'll see I got 17 slides here and we got to go through them. They'll be fairly quick. It's a lot of stuff you already know, but a lot of vocab, okay? So let's make sure that it all makes sense. And again, I'll leave it up to you to pause where you have to catch up with the ideas here, all right? Some new ideas we're going to have: central angles. We're going to talk about arcs. Circumference is going to be hopefully old to you, but anyway, a lot of the vocab, hopefully stuff you've already covered. Some of it will be new though, so let's get right into it. All right, a circle, by definition, a circle is the set of all points equally distant from a given point. So every point that's shown in red here is the same distance from the center of the circle that I've shown with this dot and labeled it P. All right, every point is the same distance from P. Okay, so we name a circle after its center, so this therefore is called circle P. And we can also designate it with a little circle symbol like that, okay? All right. So notice that all circles must be similar figures. Circle P, named after its center. Now a radius is any segment that goes from the center out to the circle, to a point on the circle, all right? So segment OA is a radius, so is OC, so is OB. All right. Now since all points on the red on circle O are equally distant from the center, all radiuses must be congruent. AO is equal to OC is equal to OB. Also notice that CB, made up of two of those segments, must be added together to be twice the length of a radius. CB is called a diameter. A diameter is a segment that connects 2 points on a circle and goes through the center. All right? Radius, diameter. Now, maybe something new here. An arc is a part of a circle. So if I were just to color this little part of the circle between A and B purple, that's called an arc, okay? Now, specifically that's called a minor arc. And a minor arc is defined as being smaller than a semicircle. A semicircle is an arc that covers half of a circle. In other words, the endpoints of the arc of a semicircle are a diameter, right? Are on a diameter. So a semicircle is half of a circle, and a minor arc like AB is less than a semicircle. Okay, a major arc is more than a semicircle. So the arc that goes from A through C all the way out to B, that is called a major arc. Now we label them differently. For a minor arc, I can use two letters. CA is the minor arc that goes from C to A. AB is the minor arc that goes from A to B. Okay, two letters are good enough. But when we get to major arcs, we need to tell the difference between them. So if I'm talking about the major arc that goes all the way around like this, I can't just call it CA, because then we would actually be thinking about this minor arc here, right? So for a major arc, we name it with three letters. CBA would be a good example of how to name that major arc. All right, ABC or CBA would name the major arc. Okay, and again, like that with our little arc symbol over it. Okay, good enough. Continuing. Now, a central angle is an angle whose vertex is at the center of a circle. So angle AOB is a central angle. So is angle AOC. Anything with a vertex here at the center of the circle is called a central angle. Okay, now we can refer to the measure of the arc by referring to the measure of the central angle that cuts it, okay? So if this angle is 30 degrees, notice how it intersects the arc at point A and B. Therefore, A and B can also, or arc AB can be considered to be 30 degrees as well. So if the measure of AOB is 30 degrees, then arc AB can also be considered to be 30 degrees. Now notice that arcs are additive as well. Okay, if arc AB is 30 degrees, well, I know that arc CAB here has to form a semicircle, 180 degrees in a semicircle, right? Half the circle. Therefore, arc AC must be 150 and just demonstrating again that they must add up, or they can add up. Okay, so for you to practice on your own, measures of arcs. Okay, pause it, think about it, here you go. Measure of arc CD must be 58 degrees because that's the measure of its central angle. Measure of arc AD. All right, AD must be 180, formed by the diameter from C to A. Okay, subtract the 58. We must have 122 for arc AD. Arc BA, it's this one here. Once again, 180 degrees, formed by CA. Subtract 32. We must have 148 for arc BA. CDA must be 180, semicircle. BDA, okay, that one's going from here around that way. It must be 180 plus this 32. Okay, must be 212. BAD goes all the way around except for that 90 degrees formed by the 32 and the 58, must be 270, and BAC must be 328. Again, yours to stop, slow down, and figure it out. It doesn't make perfect sense, okay? Now, because all circles are similar, many problems involve ratios that stay the same, no matter how big the circle. For example, thousands of years ago, some people discovered that the ratio of the diameter of a circle to the ratio of the distance around the circle is always the same. And it always came out to be this number, 3.14159. Okay? Of course, we've come to recognize that as pi, and we've come to realize that this gives us all kinds of cool stuff we can do. Now, that distance around a circle, we name it the circumference of a circle. And we use the formula that the circumference is 2 times pi times the radius, or the circumference is equal to pi times the diameter. Same thing, either works, and we can usually use 3.14 for our value for pi and find out the length of a circle in feet, inches, whatever. The distance around a circle is called the circumference. Okay, now keep in mind always, circumference, radius, diameter, they're always proportional. Okay, you may come find these proportions handy in some of the problems that you're going to do. Okay, coplanar circles. If they have the same center, they're called concentric. So here's an example of concentric circles, two circles that have the same center. Now, the difference in the circumference of these two circles, okay, well, the bigger one would be 2 times pi times r1, right? And then the littler one, 2 times pi times r2. Okay, and that can be simplified to look like this thing right there. So another handy formula for you. Sample problem, pause it, think about it. Here comes your answer. Okay, the inner wheels travel the circumference of the inner rail, or 2 times pi times 8. The outer wheels travel the circumference of the outer rail, 2 times pi times 10. So the inner wheel is 16 pi, outer wheel 20 pi. Outer wheels must travel 4 pi feet further, or about 12.5 feet. The other way to do this is to use the formula from the previous slide. 2 pi times r1 minus r2 tells us there's a 4 pi difference between the outer diameter and the inner diameter. Okay, good. All right. New idea. Okay, arc length. We've talked about the measure of an arc, like the measure of this arc is 30 degrees. Okay, but if we know, for example, the radius, and therefore we can find the circumference, we can actually find, like if this is 10 inches, I can actually find the length of this thing, not just 30 degrees, but actually the length of an arc by using the portion of the total circumference. The important idea here, guys, is that here's a 30-degree arc. Well, the entire circle is 360 degrees, right? So this must be 30 out of 360, or 1/12 of the total circumference, right? This arc here must be 60 out of the total 360, or 1/6 of the total circumference, right? A semicircle must be equal to half the total circumference. So by looking at the measure of the central angle or looking at the measure of the arc, we can always find the portion, the segment of the arc of the total circumference that is composed by that one arc. Here's what I mean. Okay, so we take the fraction formed by the arc divided by the total around the circle, and we can multiply that by the circumference and find out exactly how long the arc is. So here's an example or two. Okay, the length of arc CD, well, it's 94 out of 360 times the circumference, which is 2 pi times 5, 2 pi r. And a lot of our problems ask us to leave the answer in terms of pi, so I'm going to write the answer here in terms of pi. Then I'm going to multiply 2 pi, 2.6 times pi to give us 8.2. So if a problem says leave the answer in terms of pi, you can just leave it this way, all right? Okay. So the measure of the length of arc CD, the measure is 94 degrees, but the length, if the radius is 5, is going to be 2.6 pi or 8.2. So what's the measure of arc AD? That's this one here. Well, the measure again, I can just use the angle. It must be 180 minus 94 or 86 degrees for the measure. Now, what's the length of arc ACD all the way around? Okay, once again, I'm going to take the portion, that 180 semicircle, plus this 94 out of 360, multiply it by the circumference, and I get 7.6 pi to leave it in terms of pi, or 23.9 when I multiply it out. A couple more examples. Go ahead, stop it, think about it. Here come your answers. Length of arc CA, 180 degrees, half the circle, times 2 pi r. Oh, that's why I did this. I want you to notice also the difference here. When a dimension is listed down here, that means it's the measure of the radius. In this problem, when a dimension is listed right by the center of the circle, that means it's a diameter, okay? Kind of an important thing in doing these problems. So here I got a diameter, 5. Therefore, 2 pi r, r is 2.5, half the circle, 180 over 360. There you go. Continuing on, BOC, measure is 28, but the length of arc BC, 28 divided by 360 times pi times d, left in terms of pi, multiplied out, and finally the length of arc BAC all the way around, except for that 28 degrees, 360 minus 28, 332 divided by 360, multiply it out in terms of pi and in total inches. All right, got it. See you all soon.